Good morning, everybody. Today actually I'm going to start the remaining part of statistical parameter, which is started from harmonic oscillator. Okay, so classical harmonic oscillator I have already given you. Though now I am giving you the quantum harmonic oscillator and the related thermodynamical parameter and application of harmonic oscillator in different field of physics, starting from vibrational phenomena, spectroscopy, molecular physics, atomic physics, quantum mechanics, classical, everywhere. Okay, so I'll start from in the last class harmonic oscillator, quantum mechanical. Okay, I'm writing quantum mechanical harmonic oscillator, which is also known as a Schrödinger oscillator because we have used this formula. This is one-dimensional case, okay, and n plus half h cos omega. This is a Schrödinger harmonic oscillator, and it is equal to half h cos omega plus n h cos omega. Okay, now this half h cos omega is known as the 0-point energy of harmonic oscillator, and if we assume that there is no 0-point energy, then if this part is assumed to be 0, then equal to n h cos omega, then Schrödinger oscillator become Planck oscillator. Okay, and up to last class we have discussed the partition function for a single harmonic oscillator, one-dimensional harmonic oscillator. We are getting this value. Again I am writing b h omega by 2 e to the power 1 minus e to the power minus b h cos omega. Okay, this is the formula. Or if it is one-dimensional 1D harmonic oscillator. Okay, if it is, suppose if I use energy, I have already given you this is for this energy, one-dimensional case. Suppose if the energy of harmonic oscillator is suppose three-dimensional means nx plus half h cos omega plus ny plus half h cos omega plus nz plus half h cos omega. Suppose it is anisotropic harmonic oscillator, not isotropic. That means frequency omega x not equal to omega y, not equal to omega z. This x, y, z. It is three-dimensional case. This you will become z in 3D case. It will nothing, just product of this one. E to the power minus beta h cos omega x by 2, 1 minus e to the power minus beta h cos omega x. Okay, and then e to the power minus beta h cos omega y by 2, 1 minus e to the power minus beta h cos omega y by y. Then third term e to the power minus beta h cos omega z 2, 1 minus e to the power minus beta h cos omega z by z. This is okay. This I have already given you. So, and it is three-dimensional case. If the system composed of n number of one-dimensional harmonic oscillator, then it will be z total z equal to z to the power n to the power n. Okay. Again, if this n-dimensional n numbers of one-dimensional harmonic oscillator, if it is indistinguishable, then 1 by factorial will come out. Okay. Now I am considering harmonic oscillator, all are distinguishable, and that is why I am not writing 1 by n factorial. Okay. So this part already I have tell you in the last class, but why I am telling you again, so that you can understand the remaining part of the thermodynamical parameter. That's how I am going to calculate. Okay. So partition function I am starting from here. Z equal to, this is for e to the power minus beta h cos omega by 2, 1 minus e to the power minus beta h cos omega by 2. Sorry, not 2. This is what I can express. It is like that. If I divided both part 1 by, if we divided the numerator denominator by this one, this will become 1. E to the power minus it will become plus b h cos omega by 2, minus e to the power minus b a square by 2. Okay, and it will become what? It will become 1 by 2 sine hyperbolic beta a cos omega by 2. Remember. Why? Because you remember this formula, e to the power x plus e to the power minus x equal to 2 cos hyperbolic x. Okay, and e to the power minus x minus e to the power minus x equal to 2 sine hyperbolic x. This formula you remember. Okay, now again another formula I am giving, I am going to use this cos hyperbolic x equal to, is cos is a even function, so only even term will be there, 2 factorial x all are plus 4 factorial plus the dot. And similarly sine hyperbolic, sine is a hyperbolic x is a odd function, so it will be first term x, second term x cubed by factorial t plus x5 by factorial 5. This formula you have already studied in PhD as well as high secondary, and this formula I am going to use this in deriving the calculation. But this calculation this calculation using this exponential series and special case, sub case, under what condition, what will happen, this parameter. So this you are not discussed in Pathria book. That's why I am giving you in detail so that you can understand this one. And another thing I like to tell you, that whatever theory applicable, very important for us, I have given all the detail from Pathria book. Okay. Now whatever portion I am teaching here, no need to study this part. You just try to understand, solve the numerical problem, and you can do all the you can easily solve all the question asked in the exam. Okay, this is formula you remember. This formula I have given you. This is for single harmonic oscillator. For n dimensional n numbers of oscillator, it will becomes this one. Okay, this to the power e to the power minus beta a cos omega by 2, 1 minus e to the power minus beta a cos omega to the power n, or you can this one also, any one you can do as per your requirement. Sometimes what happen in exam you don't think that you have to derive partition function, you have to derive free energy, you have to entropy, everything. They are not going to ask you everything. They will ask to do what is the partition function of harmonic oscillator with this energy. They will ask this, or either they will ask they will tell if the partition function of a harmonic oscillator this one, then what is the partition function at high temperature? They will ask this one. Okay, or what happened at low temperature, or if the partition function of a harmonic oscillator this one, what is the free energy? So that's what they are going to ask. So one formula they will give you, and next parameter you have to calculate. That's why I am giving you the parameter calculation in detail, how to analyze, what are the parameter you have to derive. Okay. And is this equal to, I am simplifying this equation. You can this will become same formula, 1 of beta a cos omega by 2 minus e to the power minus beta a cos omega by 2 to the power n. Same thing, you can do the same thing here also, to the power n. Okay, as per your requirement. This is for one dimensional harmonic oscillator. For n numbers of one dimensional quantum harmonic oscillator, this harmonic oscillator is known as a Schrödinger oscillator. Because why? Because we consider 0 point energy. Okay. Clear? Now see. Now yesterday I have given a case 1, case 2 study. Suppose case 1 study. So what type of equation they often ask? They will give this one, partition function of single harmonic oscillator. They will ask him what happens when beta is very greater than is cos omega. Beta is very greater than energy. Then or they can say beta tends to infinity. But one thing you remember, beta tends to infinity does not mean that beta equal to infinity. Okay. Why beta tends to infinity? See, beta tends to infinity means what? Beta equal to 1 by kt tends to infinity. Okay. Tends to infinity means t tends to what? T equal to what? T equal to 1 by k tends to infinity equal to 1 by tends to 1 by infinity equal to 0. Why? any number divided by infinity is always 0. It's not equal to 0, exactly tends to 0. Okay, so this beta tends to infinity means t tends to or t tends to 0. Clear? So if beta tends to, you can transform this equation. Then what happens? You can say if it is beta tends to infinity or t tends to 0, t beta means 1 by kt. Okay, then what happens? E to the power, under this condition, e to the power, it will become what? Beta is infinity. You can put this value, you can put this value. It will give same value. It is infinity. So 1 minus e to the power minus infinity. So another question, e to the power, you never confuse e to the power minus infinity equal to what? 1 by e to the power infinity, right? 1 by e to the power infinity. 1 by e to the power infinity means 1 plus infinity square by factorial to something like that. Okay, 1 plus infinity means what? Infinity. So it will be 1 by infinity. 1 by infinity is 0. Okay, that is why e to the power minus infinity is 0. Okay, but e to the power infinity is always equal to infinity. E to the power 0, correct? 1 minus e to the power minus infinity 0 equal to 0. That means what? At low temperature there is no possible microstep because Z represents number of microstep. Okay, this is in case 1. Case 2, I will study case 2. Case 2, when beta tends to 0, or same way, if beta tends to 0, t tends to infinity. Then what happens? See, if this expression, if this is what happened. So now what is the problem? Problem is that when beta tends to infinity, t tends to infinity. T tends to infinity means, okay, if it is in e to the power 0, 1 minus e to the power 0, you will get the same value. But this is not the way you have to put. Okay. When t tends to infinity means when temperature is very, very high. Then we are not going to calculate. Suppose you consider this part. Which one is, you can take any part. This one also you can take. This one I am taking this one. I am not taking this one. You can take also. If t is very high, I am not going to consider. I am taking first this one, then this one, then this one. Everything will give same result. So I am taking only one term, beta is cos omega by 2. So from where I am getting this value? From this value. 1 e to the power x means 1 plus x square by factorial to something like that. Okay. So I am not going e to the power minus beta is cos omega means I am considering first two term, 1 plus beta is cos omega by 2. Okay, first two term. Otherwise everything will become 0. Okay, so minus this term, 1 minus beta is cos omega by 2. Okay, it will what happen? 2 this become beta is cos omega 1. Okay, beta is cos omega 1 equal to what? Equal to kt by is cos omega. So this is what? This is what in classical oscillator I have already calculated. So what happened at temperature, very high temperature, this quantum harmonic Schrödinger oscillator become classical oscillator. Okay, or from you can see from here, from this equation you can check it also. Suppose I am writing here 1 by 2 sine hyperbolic x. What is the formula of sine hyperbolic x? E to the power sine hyperbolic x, I have given the formula x plus x cubed by factorial t plus dot dot. So I am writing first term will be what? X means this part. So beta is cos omega by 2. Next part 1 by factorial t, beta is cos omega by 2 cube, something like that. Okay, this is what going to happen. So beta means 1 by kt. So if temperature is very high, that means this term tends to 0. This term also tends to 0. But this term we have to consider, otherwise everything will be 0. First term you have minimum term. Temperature is high, but it is not till the t equal to infinity. Okay, t tends to infinity does not mean that t equal to infinity. Okay, t tends to infinity means t is very high. So this term become more. This term become. This is I am simplify one step more. So 1 by 2 h cos 2 kt, right? This one by factorial t, h cos omega 2 kt cube, something like that. Okay. So if temperature is very high, this term is obviously tends to very small, and remaining part tends to 0. So that is why I am considering first term equal to approximately equal to 1 by h cos omega by kt. This means kt by h cos omega. Okay. This means at temperature very high, quantum oscillator, I have already told you, it becomes classical oscillator. Okay, clear up to this part? Now in exam, this is the first question I have told you. This is possible question. First question is that if they will give an energy expression, harmonic energy expression, you have to find out any partition function for one harmonic oscillator or n numbers of oscillator. Okay, clear? If it is one dimension, then one term will be there. If it is two dimension, then product, same term you have to product. Okay. Now, if the partition, in next question, if the partition function of the system is given, then what is the free energy of the system? Suppose partition function of a one-dimensional harmonic oscillator is given. This one I am giving here. Partition function one-dimensional system and n numbers of system, e to the power minus beta h cos omega by 2. Okay, 1 minus e to the power minus beta h cos omega by 2. I am writing this into 2 to the power n for n numbers of one-dimensional harmonic oscillator. Clear? So, what is the free energy? First, I will calculate free energy. Free energy. How to calculate? Free energy is very easy formula. Free energy A equal to minus kT ln z. Remember. So, one question in the last NET exam asks from this free energy expression. Okay. So, that is why free energy calculation, first term will be what? Minus kT. Okay. Then n, then ln e to the power minus beta h cos omega by 2, right? First term, and n will come here. Okay, second term will what happen? Minus ln 1 minus e to the power minus beta h cos. This is not 2 by 2. Okay, this is free. Okay. So first term becomes what? First term becomes kT into this minus plus beta h cos omega by 2. Beta means 1 by kT. I am writing directly kT. Okay. Second, n is there. Second term is positive. So n kT. Clear? Then ln 1 minus e to the power minus beta h cos omega. Clear? This is the answer. So kT cancel. So n is half h cos omega plus ln 1 minus e to the power minus beta h cos omega. So every time I am not going to calculate the special case. I have given you the way how to calculate the special case. After that, you have to calculate the special case. Okay. In the last NET exam question, what is the average free energy of the harmonic one-dimensional harmonic oscillator? So average free energy A by n equal to half h cos omega plus ln 1 minus e to the power minus beta h cos omega. So this is what? Half h cos omega is a 0-point energy. So average free energy of one-dimensional harmonic oscillator equal to the 0-point energy of the harmonic oscillator. Okay, clear? But this is for only Schrödinger harmonic oscillator. If we consider 0-point energy is not considered, then what happens? This is if the 0-point energy is not considered. This is only for one-dimensional Schrödinger harmonic oscillator. If 0-point energy is not considered, this term will not be there. Then average free energy becomes this one. Okay. Then now at temperature is very high. Beta means what? kT. At temperature is very high. This e to the power, suppose T tends to infinity. Infinity means very high. So h cos omega by kt tends to infinity. Sorry, tends to 0. So 0 means 1 minus e to the power 0 means 1. So 1 minus 1 ln 1, ln 0 1, and this is equal to half h cos omega plus 1. Clear? This way you will have to ask a question. Clear? Now what I am getting, free energy I am writing again to tell you the details. A free energy equal to n half h cos omega plus ln 1 minus e to the power minus beta h cos omega. Clear this one? Okay. This is 0. This is free energy of n numbers of one-dimensional harmonic oscillator. But if I ask you, if this is a free energy of n one-dimensional harmonic oscillator, what is the free energy of a crystal having n numbers of atoms? Then remember, I have one single atom. One single atom is equivalent to 3 harmonic oscillator. Okay, so n atom means thrice n harmonic oscillator. So in that case, you have to multiply by 3. Then free energy of a crystal, it will become thrice n half h cos omega plus ln this part. Clear? You understood, right? So this is where you have to understand the physics. Now this is the free energy. Now what are the parameter we can calculate? You can easily get. Okay, because yesterday I have given you the formula A equal to U minus TS in canonical system. This one. From this equation D, I am giving you dA, du, TDS, S dt. This is differentiation. Okay, plus mu dn. Du equal to TDS minus PdV. So S dt plus minus PdV plus mu dn. So how can I calculate this one? Pressure, entropy, chemical potential. Now I am going to calculate the chemical potential. This is a free energy. Second question, chemical potential. Chemical potential, what is the formula according to this lesson? Chemical potential equal to dA by dN. This is the formula. Okay, with T and V constant. T and V constant. So sometimes what happens, if you will give, suppose this is a free energy for n numbers of one-dimensional oscillator. Suppose I remove the n. This is the free energy for one-dimensional harmonic oscillator. Then what is the chemical potential in this case? Because this is a differentiation with respect to n, this is become 0. No need to do anything. So first you are understanding the question. How to understand? That you have to see whatever expression given in a question, whether it contains n or not. Total number n is not there. So that means no need to calculate. Chemical potential is 0. It's become 0. No need to do anything. Just keep the 0. Okay. Suppose I am doing here. So what is it? In that case, this whole term is constant. So chemical potential is equal to what? In this case, equal to half h cos omega plus ln 1 minus e to the power minus beta h cos omega. Okay. So chemical potential is also become this one is equal to the what? This part is 0 point energy. Okay, but one thing, if we consider Schrödinger oscillator or Planck oscillator, then how can I calculate partition function for Planck oscillator? What is a partition function formula? I am Planck oscillator. Okay, Planck oscillator. I will do again calculation for Planck oscillator, but for this understanding I am telling you. So Planck oscillator is energy is this one. 0 point energy is not considered. Any 0 point energy is not considered here. This is known as the Planck oscillator. Then if I calculate partition function, sum of e to the power minus beta er. Okay, er. This is what? E to the power minus n beta h cos omega, right? So n means this is what? Sum of e to the power minus beta h cos omega to the power n. This I will take x. Then what happens? This summation x to the power n. This will expand 1 plus x square plus dot x cube. It will give what? 1 minus of x 1 series. So then what happened? Equal to 1 by 1 minus x. So finally what I am getting for Planck oscillator, I am writing again Planck oscillator, I am getting partition function 1 by 1 minus x equal to how much? So this happened 1 minus e to the power minus beta s cos omega. This is the partition function for Planck oscillator. 0 point energy is not considered. Okay, in that case this part will not be there. Remember, if you do calculation for taking the partition function, this one for whole system partition function 1 minus e to the power minus beta is cos omega to the power n. If you take the partition free energy using this calculation, this term will not be there. Similarly, if you do calculation chemical potential, I will discuss this part again. Okay, this first part will not be there. Okay. Now what happened? If beta tends to infinity, means temperature tends to 0. If beta tends to infinity, then this e to the power minus infinity equal to 0. So ln1 equal to 1 0. So it is equal to half square. Now question may arise. Okay, when beta tends to infinity, so if this free energy, okay, they will give you, if the free energy of one dimensional harmonic oscillator d1, that what is the chemical potential at beta tends to infinity. Beta tends to okay, question you understood. The question is given that if the free energy of n numbers of harmonic oscillator is given by this one in that question, and what is the chemical potential when beta tends to infinity, or beta tends to infinity, or beta is very greater than s cos omega. Then what happened? What happened to this? So beta is very greater than, or you can say beta equal to is something like that. Beta is s cos omega by kt is greater than 1 something, and s cos omega is greater than kt. This is also given like this also. Okay, do not confuse this condition. When temperature is beta tends to infinity, means temperature tends to 0. Okay, then what happens? If beta tends to infinity, this term is become 0, then ln is 1 and chemical potential equal to half 0. The question is arises, when beta tends to infinity, what is the chemical, which of the following question is correct answer chemical potential at this condition? That chemical potential equal to 0 point energy of a harmonic oscillator. Okay. So chemical potential I have already calculated. What is the entropy? Now third term we have to calculate entropy. What is the formula of entropy? This equation, again I am telling this equation. No, why I am every time giving this relation? Because there is a two relation, and from where you can calculate all thermodynamical parameter. One is dq, thermodynamical relation, du plus pdv. Okay, dq means tds equal to du plus pdv. This is the relation, first relation. Second relation is that a equal to u minus ts plus mu n. These two relation, from these two relation you can derive every parameter in thermodynamics. So every time you focus on this parameter. So already I have, after differentiation, what I am getting, dA equal to minus s dt minus pdv plus mu dn. This relation I have already derived. So first question is that, because what is the entropy? Entropy equal to minus dA by dt when volume and n constant. Clear? This is the relation. So from this relation, once in question and free energy of the system is given, then if you want to calculate, you just remember these relations, nothing else. So free energy already I have derived. So free energy what I am getting? Free energy I am getting, and this is okay, and half is cos omega plus ln 1 minus e to the power minus beta is cos omega. This is the free energy of the system. Clear? So entropy is just differentiation of this part dt. First term will become 0. second term is what? Yeah, dt is there, you remember. Okay, t is there, beta equal to 1 by kt. So don't confuse. So you have to differentiation 1 minus e to the power minus beta is cos omega. Then again differentiate dt e to the power minus beta is cos omega. Okay, do two differentiation. So it will give you and first term is 0. It is first term is 0 term. Next term is what? What do you will get? First term is 0. Second term is minus e to the power minus beta is cos omega, right? And minus is there, d by dt beta is cos omega. Clear? 1 minus e to the power minus beta is cos omega. What you will get? What you will get? Equal to h cos omega beta minus plus h cos omega will come out and h cos omega e to the power beta is cos omega 1 minus e to the power beta is cos omega. Then what happened? And minus 1 by beta means kt, k t square. Clear? So finally you will get a, I'm not going to give you a detailed expression. Finally you will get expression. You do this is simple calculation. I'm not going to do the detailed calculation. Finally you will get entropy equal to nk beta is cos omega e to the power beta is cos omega minus 1 minus ln 1 minus e to the power minus beta is cos omega. This will value you will get. Okay. Clear? This is the entropy. Now what next question is that what mean energy? Mean energy. This mean energy is very essential. So mean energy from where you can calculate mean energy? Mean energy you can calculate using this formula A equal to U minus ds. Here I am not writing mu en. Okay. Because I am considering n is constant. So that is why this part is not written. You can express also, no problem. Mean energy U equal to A plus ts. Okay, you can calculate. Entropy we have calculated, A we have calculated. Suppose in exam what happened, if entropy is, because free energy is given, but entropy is not given. In that case, if you want to calculate mean energy, first of all free energy, from free energy you have to calculate mean energy. Entropy. Then you have to calculate the free total energy. But in that case, you can convert this formula A equal to minus T. S is equal to how much I have already given. S is equal to dA by dt. Okay. P n. So this equals to you can write dA by dt. In that case, what happened? In exam, suppose in exam A free energy is given. Suppose n half h cos omega plus ln 1 minus e to the power minus beta is cos omega. This part is given. Then what happened? Again, if you want to calculate mean energy, then you have to calculate entropy. Then you can find out the mean energy. This is a long procedure. So in order to avoid time, you can entropy you transform to mean energy, and now dA by dt you can calculate and put this value here. Okay. This is under one method. This is one method. Suppose in exam what entropy is, free energy is not given. only the energy of the harmonic oscillator En equal to n plus half a square omega, calculate the mean energy. Then how can you calculate the mean energy? Mean energy calculation I have given you. This is the formula. I have already given you beta ER. This is ER. This is mean energy means this one. Okay, do not confuse. Mean energy, U means mean energy. You can express the E, or sometimes we express the only E. We understand. So e to the power minus beta ER. Okay. So this is the formula. Directly we can calculate the mean energy. So mean energy calculated. What is the formula? Sum of n plus half. What is the energy? H cos omega. E to the power minus n cos half beta H cos omega. Similarly here, e to the power minus beta into n plus half H cos omega. Correct? Correct? Okay. In the next step, I remove this part. E to the power minus beta H cos omega by 2. Sum of e to the power minus beta n H cos omega. Right? Similarly here what happened? This term I can remove it. N plus half H cos omega e to the power minus beta H cos omega by 2. Okay? E to the power minus n H cos beta. Correct? This term will cancel out. This term, this is a constant term, it will cancel out. I can express this is e to the power minus n beta H cos omega, and half H cos omega will also come out. Half H cos, this is what? Sum of n plus half e to the power minus n beta H cos omega. Clear? Okay. Next step will what happen? This already H cos omega is there. So next term, first time you have to do this calculation. Next time I can expand. See, the second time I am writing first half is there. Sum of e to the power minus beta n H cos omega. Sum of e to the power minus beta H cos omega n. Okay. Next term, this is a factorization method. Next term I e to the power minus n beta H cos omega. Sum of n beta H, n is there, e to the power minus beta H cos omega. Okay. Now this term cancel, equal to how much? H cos omega into half plus, this is what already blackbody radiation I have calculated. Take e to the power n is there, n is there. So e to the power x, n, x to the power n, and x to the power n. So it will what happen? Finally I will get 1 minus x. Okay. So I am writing again here equal to what I am getting here. What I am getting here is cos omega, then half plus x by 1 minus x. Clear? I am erasing this part. This is equal to half H cos omega plus H cos omega into, this is what? X equal to, I consider e to the power minus beta H cos omega. 1 minus e to the power minus beta H cos omega. Okay, clear? So I can transform into half H cos omega plus H cos omega 1 minus e to the power H cos omega beta minus 1. Or you can write this expression H cos omega. And this is a blackbody radiation calculation. Okay, this is 0 point energy. What you understand, if 0 point energy in the expression, if we do not consider En equal to n plus half H cos omega, if you do not consider this part, then this part will not be there. Then it will be calculation Planck oscillator, whatever we have done in blackbody radiation calculation. But it is photon, this is harmonic oscillator, there is a photon. Okay. This is what for mean energy, and do not confuse, this is the mean energy for single harmonic one dimensional oscillator. Okay. So total mean energy of the system, mean energy of the system n into half H cos omega plus H cos omega e to the power H cos omega beta minus 1. Okay. But if we suppose, if we consider En equal to n plus half h cos omega, in exam what happened? I have seen a question, they given alpha plus n beta. So question is like that, if energy of a harmonic oscillator given as a alpha plus n beta, okay, then what is the mean energy of the system? That is nothing, just you remember, here beta is constant, alpha is constant. Beta is not that, in that question beta is not represent 1 by kt. Okay, beta is constant, alpha, beta, gamma, like that. So in that expression, no need to, you just remember this equation. So first term, whatever, if half h cos omega is represented by alpha, so first energy, mean energy will be alpha, second term will be beta into this term, h cos omega beta minus 1. This is a beta, this is constant, or you can transform to another form, gamma. Okay, then gamma is there. This is the energy expression, remember. Okay, and if this not alpha part is not there, if energy expression is a n gamma, then energy will be, what is the mean energy? No need to do anything, gamma will be there, and 1 by e to the power h cos omega beta minus 1. Just do it, just remember this expression. Okay, this question comes in an exam. They will not giving, they are giving like this. If alpha and beta, NB, alpha, beta constant, what is the energy, mean energy? Then this is. So this is you see, this is the mean energy of quantum harmonic oscillator. Okay, and what is the classical mean energy of classical oscillator? I have already given you calculation. What is a classical oscillator? Classical oscillator, 1D harmonic oscillator, Hamiltonian is represented this one, according to equipartition theory. This is classical 1D harmonic oscillator. According to equipartition theory, how much energy? Half mean energy is equal to expectation value of px square twice m expectation value of half k x square. This is a 2 degree of freedom 1, 2 is a half kt plus half kt equal to kt. So one dimensional case, mean energy is kt. For n one dimensional classical oscillator, and mean energy how much? N kt. Always remember. But here what happened? One dimensional harmonic oscillator mean energy, we are getting this. This means what? Quantum harmonic oscillator never follow equipartition theory. Remember. Okay, this question also asked in the GATE exam. The which of the harmonic oscillator never follow the equipartition theory? Equipartition theory is never followed by quantum oscillator, which is quantum oscillator means Schrödinger oscillator as well as Planck oscillator. And if it is Planck oscillator, then mean energy will be h cos omega e to the power minus n is there, h cos omega beta minus 1. It is Planck oscillator. It is Schrödinger oscillator. Okay. This is a mean energy. So you can calculate the mean energy this way also. This I have already given you mean energy calculation, and this is already this theory. This theory is Planck oscillator and Schrödinger oscillator. In Pacific debate theory, they have used this theory. They have used Planck oscillator. But after what actually Planck and Einstein and Debye model going to calculate? Einstein and Debye model going to calculate the passivity of solid. Solid means passivity due to phonon interaction. Phonon is boson. Okay. And if you do this calculation using Schrödinger oscillator, you will get the this energy. And if you do the Planck oscillator, you will get this energy, mean energy of a crystal. Okay, this is for one dimensional n harmonic oscillator. I have already told you n atom means Thyssen harmonic oscillator. Then you have to multiply by T. This is energy in passivity solid. Remember. But using Schrödinger oscillator, you will get this expression. Using Planck oscillator, you will get this. This equation already used in Debye and Einstein model. Okay. After that, there is an integration that I will discuss after this portion. Okay. Now what happened? Now I am writing again so that it is clear. It is a mean energy for n oscillator. Mean energy for n oscillator, n one dimensional, sorry, mean energy n half h cos omega plus h cos omega e to the power beta h cos omega minus 1. Okay, 1. Another mean energy for this is beta h cos omega minus 1. This is for Planck. Okay, Planck means 0 point energy is not considered. This is Schrödinger. 0 point energy is considered. Schrödinger oscillator. If it is crystal, suppose 3D crystal means n numbers of atom means Thyssen oscillator. This will become equal to Thyssen, this expression half h cos omega plus h cos omega e to the power beta h cos omega minus 1. Clear? And this expression Thyssen h cos omega beta h cos omega minus 1. Okay, and in crystal, if you do Schrödinger oscillator, you will get this. If it is considered Planck oscillator, you will get this. This one is used in Einstein model. And after that, if this is the average, average energy, mean energy. If you multiply with average mean energy with density function, you will get the total energy in a crystal. Clear? But in Einstein model, what is their aim? Their aim to calculate the passivity of solid due to Faraday interaction. But passivity is du by dt. Okay. Volume is constant. Passivity at constant volume is du by dt, right? So if you do the calculation using this formula, your answer will be same because first term is constant. Du by dt, this term is 0. So this term is 0. This term will not be 0, and this term is 0. So there is not this term. If you add a constant n numbers of constant term, passivity will not affect it. Okay. So in Einstein model, if you use Schrödinger equation, you will get the same result. If you use Einstein model, you will get the same passivity. Does not affect because this part is constant. So in net gate question, this type of conceptual question asks. Okay, suppose if I give you, suppose energy 1 is energy, mean energy. This is the energy expression of 1 and alpha plus beta plus n gamma. This is the energy 1 expression in crystal. This is energy of a suppose 1 particle. This is suppose energy of the another particle, n gamma. Okay, and suppose passivity is CV1. This is CV2. No, this type of question often asked. This is a conceptual question. If this is the energy expression and passivity of this particle is given by CV1 and passivity of under this energy expression is passivity CV2. Now my question is whether these two passivity equal? Equal, because this passivity CV is du by dt. So if you do calculation this year, so you will get a same, suppose you are getting m value. M is unknown, I am not writing m. And this CV, in this case, you also get m. Because this is a part constant, this is always 0. So presence of absent doesn't matter. But passivity is constant. Okay? Now I am going to calculate the passivity of one-dimensional harmonic oscillator. Passivity calculation, CV, I am not going to, because of time constant, current is also not available. Okay, passivity equal to du by dt equal to, if you do the calculation, I am not going to do calculation, nk beta is cos omega square e to the power minus beta is cos omega plus e to the power beta is cos omega minus 1 square. Okay. This is the, remember, this is the specific heat of n one-dimensional harmonic oscillator. Now if you multiply with T, suppose T and K, beta is cos omega equal to beta is cos omega e to the power minus beta is cos omega minus 1 square. This is the passivity of three-dimensional harmonic oscillator. Okay, and which is known as a specific heat of an atom in in three-dimensional crystal. Okay, this is a passivity. And this theory, if you see the Kittel book or Decker book, you will get this is the passivity of n crystal. And now if you multiply the base density of function and then do integration, you will get, suppose total passivity, this is suppose I am writing x. Total suppose t n k, okay. Then the h cos omega, then beta e to the power beta h cos omega 0 to infinity e to the power beta h cos omega minus 1 square d d. This is the divide theory. Remember, this is the divide theory. I will discuss later. This is the passivity of Thyssen harmonic oscillator. Three-dimensional harmonic oscillator means n crystal. Okay, this is the passivity. Why I am taking 0 to upper limit? According to divide theory, according to Einstein theory, all the harmonic oscillator independent. They vibrate at a common frequency. But according to divide, they consider that harmonic oscillator have different frequency in continuum form in the limit 0 to infinity. Any value of frequency it can vibrate, but it is not identical. Vibration of n atom is not identical. So every atom vibrate at different frequency. And range of frequency 0 to infinity. That is why they do integration. Okay, and if you do the calculation at low temperature, you will get the passivity at TQ. Okay. So that's why in passivity of solid, I'm giving you hints so that you can understand. Passivity of solid at low temperature, always remember, low temperature is equal to alpha T plus beta. Beta is constant. Okay, no, it is not equal to 1 by kT. Beta is constant. If you confuse, you can use gamma also, no problem. D by, this is general formula, D by S. Okay, passivity not equal to proportional to TQ. It may be any other form, for it is a d-dimensional crystal. Okay, S means dispersion relation. Okay, I am talking about passivity of divide theory phonon. Phonon is boson. There may be passivity of any other particle which are also boson. So that is why I write general formula. Suppose if it is phonon, phonon is boson. What is phonon and photon have the same rule? Energy equal to how much? Pc. Because I derived this formula, P square equal E square equal P square C square M naught C to the power 4. This is relativistic relation. For S mass of phonon is 0 and photon is also 0. This part will be 0, so E equal to PC, right? So E equal to 1. E equal to H cos K C. That means E proportional to K. This is 1. This value is known as a S value. Okay? This is known as a dispersion relation. So in passivity, if it is three-dimensional crystal, 3D crystal, D equal to T alpha T plus gamma T, T by 1, it will be alpha T plus gamma TQ. Okay, remember, this is the passivity of three-dimensional crystal for phonon, which are boson. There may be any particle which are also boson, may not be phonon. Then what happens? Passivity this one. So passivity, low temperature, this first part is called electron contribution. It is derived from where? Fermi electron model. And second term is derived from where? Debye model, Debye-Einstein model. Remember, okay? This is for Debye model. If it is three-dimensional, 3D. Suppose in 2D case, I am giving you again 2D case. This alpha T is beta, gamma T. D is 2 dimension 1 is equal to alpha T plus gamma T square. So it is for 2D. This is passivity of solid Debye model 2-dimensional crystal. Okay, for phonon having dispersion relation, this one. If the dispersion relation will be different, then this relation will become different. Okay. So 1D crystal alpha T plus gamma T. So it will what? Alpha plus gamma T. Remember, this is for one-dimensional formula of passivity solid of Debye theory. Clear? This we will this is I'm giving a hint how it is related to this calculation. Harmonic oscillator calculation is how related to physical phenomenon. For example, I'm giving one example, Debye-Einstein model, and I will discuss again application of partition function in Debye-Einstein model. I will derive every theory, okay, in my way. Clear? So after finishing, this is the first application of partition function in harmonic oscillator. Classical harmonic oscillator, quantum harmonic oscillator. There are two harmonic oscillator, Schrödinger oscillator and Planck oscillator. Planck oscillator is nothing, same calculation, only you remove half h cos omega and every calculation will remain. So if you record, I can give you, no problem. It's simple calculation. I have already given in black body radiation calculation. Mean energy, mean number of photon, also given in semiconductor class. Okay. So I'm shortly, for your better understanding, I'm briefly writing you a table. Energy table. This is energy. This is mean energy. This is specific heat. CV. Okay, specific heat CV. I'm not writing it because it will take time. CV for harmonic oscillator, and this is CV for crystal. How calculated? Okay, this table you can understand the comparison. If I take the mean energy n is cos omega, this is Planck oscillator. Okay, Planck oscillator. This is En equal to n plus half h cos omega. This is 1D. Okay, 1D. This is h cos omega. This is 1D. Okay, this is Schrödinger oscillator. Okay, mean energy, in this case mean energy you will get n h cos omega e to the power beta h cos omega minus 1. Okay, mean energy. And specific heat you will get in this case nk h cos omega by kt square e to the power h cos omega beta e to the power h cos omega beta minus 1 square. This. Okay, this is specific. If we do calculation mean energy for Schrödinger equation, I have already given you n half h cos omega e to the power beta h cos omega minus 1. And specific is equal to nk, same, beta h cos omega square e to the power minus h cos omega beta e to the power minus h cos omega beta minus 1 square. So it is for n-dimensional and one-dimensional harmonic oscillator. In crystal, say this is, suppose I am writing this is suppose x, then it will be thrice n x. Only 3 multiply. Here is equal to thrice n x. Okay, x, this is x part. This is x. So what you understand, even if you consider Planck oscillator, you will get the same specificity. If you consider this is specificity, you will get the same specificity. Okay. So specificity does not depend on 0-point energy. That's what I am telling you. On only crystal, if you multiply, then this is an Einstein function. If you see the Peter book, you will get that this is known as the Einstein function. And these two expressions used in Debye-Einstein model, I will discuss you later. So in both cases, in these both cases, the specificity remain constant. Okay. So for you better, this is what happened. This is Einstein Debye model. This equation. This at Tnx for n-dimensional n crystal. N crystal means thrice n harmonic oscillator. Thrice n, whatever we are getting for n oscillator here, it will be 3 times more. Whatever we are getting here specificity for n number one-dimensional oscillator, you will get a 3 times. If it is 3 times, then it will become a crystal. Okay, clear? So in books you will get this formula. So in books you have got this formula. Now I am questioning specific heat. Suppose one-dimensional specific. If I ask you a crystal of one-dimensional crystal means what happened? One harmonic oscillator. Suppose harmonic oscillator I am writing the like way. Suppose p square x square twice m plus half k r square. It is 3D. So one dimensional crystal means only px square by twice m plus half kx square. 1D. This is 1D case. Crystal. 1D crystal means CV for 1D crystal equal to what? In classical theory, half kt, half kt, kt. For n crystal, n kt. Okay? Kt will not be there, half. For passivity equal to half k plus half k equal to k. For n atom, n oscillator, it will be n kt. It is for 1D. Remember, if two dimensional to 2 n kt. If it is three dimensional, 2D, it is 3 kt. Oh, sorry, kt is not there. Tr. Tr means what? 5.96 calorie Kelvin inverse. This value you are often getting in the books. Okay. Tr. It is for Tr means 5.96 calorie Kelvin inverse. Okay. This value you will often get in the books. Do not confuse. This is only for 3-dimensional crystal. But 2-dimensional it is twice nk. 1-dimensional nk. That means nk means what? R twice r. It is thrice r. 1D, 2D, 3D. So in divide this expression, I will get in detail, but you are giving is you see this expression you will get in divide theory. T temperature, this is passivity, this is classical value. Classically, this is a classical value. Classically, passivity is a constant, which is equal to Tr. That is why this is a classical value thrice r equal to you can 5.96 calorie Kelvin inverse. And this theory is given by who has given this theory? Dulong and Petit-Long. Okay. And another equation is this one. This is d by, and this is Einstein. Okay. And T cube law is this one. This is formed as a T cube. This is T cube law. Okay. So d by theory more close to the experimental value. That's why we often consider d by theory is acceptable from. And Einstein theory little bit deviated from Einstein d by model, and also high deviation from experimental value. But experimental curve is not exactly similar to the d by model. But d by theory passivity is more close to the experimental value. That's why we often consider d by theory. Okay. Thank you. In the next class, this is the application of partition function. In one application I have already completed. Clear? Any question? After this application, I will go to the paramagnetism and ferromagnetism. This is another application. Third application is third application is not already in Pathria book, but I have included third application, Einstein and d by model. After completing this part, this chapter is finished. Okay, whatever I have given you, you just study regularly. Only this portion of question will come from this portion. That is why I want to include more application in this chapter number 3 of statistical books. That's why I am pausing all other classes. Once it is complete, then the rest of the physics you can easily understand. Okay. Okay, thank you.